Hey everyone, welcome back to the channel, and today we're diving into one of the most powerful tools in Blender, geometry nodes. If you've ever wanted to create complex models, repeating patterns, or animated effects without manually modeling every detail, geometry nodes can completely change how you work. By the end of this video, you'll understand what geometry nodes are, why they're useful, and we'll build a simple procedural model together from scratch. Consider this the column generator. So what are geometry nodes? Geometry nodes are a visual, node-based system in Blender that lets you create and modify geometry procedurally. Instead of destructively modifying your mesh in edit mode by just moving vertices around, if I wanted to get rid of that, I would have to Control-Z to undo those actions. Whereas geometry nodes, if I want to alter a mesh, I can always go back to where I started. Think of it like this. Traditional modeling is like sculpting clay by hand, and geometry nodes is writing instructions for how the clay should shape itself. The big advantage is that it's non-destructive. You can go back anytime, change values, swap objects, or reuse the setup entirely. Why use geometry nodes? They're especially useful for repeated structures, procedural environments, motion graphics, or abstract generative designs. Here are the nodes that we're going to need to create a procedural column. We have our curved line, our cube, which is going to be instanced on our curved line at the start point and the end point, and the inner cylinder, which determines what the inside of our pillar looks like. And we unify the cubes and the cylinder. And as you can see here, we're going to use this curved line for both our cube and our inner cylinder. So first we are going to start off with a fresh object here. Shift A to add an object here. You can add a plane or whatever you want to do. Open our geometry nodes and name it something like column generator tutorial. And if you have items grouped, like if you have nodes grouped, you can either go into another one like this, copy these, and then paste it into here like this, or you can just Shift A, search, and add a column tutorial node, right click this and ungroup, or Control Alt G, and it brings in the same thing. We don't need this initial geometry input, so we'll go ahead and delete that. We'll start off with our curved line. This line is 1 meter tall, and this is going to be our height of the column. So in order to get that column shape, we're going to need our cylinder. So in order to use this the way we want to be able to see it, right? So we can put our curved line into our curve to mesh, and then use a star curve as our profile. Now I've got these set a specific way because this is what I like for this particular instance. But you'll notice here, if I look at this star curve, yeah, that's pretty much the shape that we want, but it's kind of too pointy here. So what we can do is we can add a fillet curve, and what that does is rounds those edges there based on a poly count or a Bezier. Bezier is going to give you more of that kind of blocky gear look, but poly count is going to be what we're going to do. So this radius here is just how bent, how wavy are these lines here. I like a value of about 0.02 for that, and I put that into our profile curve. So we've got this so far. So I like the way that looks. Here's our cylinder, main cylinder part for our column. And the amount of points, I want to tie that to the resolution of the cylinder. So what we'll do is we'll do a group input, and then that value right there should show up here. To change what it says, hit the N on your keypad, double click that, and type in resolution. And now this is your resolution. So anytime that you want to use this group input, you can just Shift A, add a group input, and it will show geometry and resolution. We're going to be adding more to this as we go along here. So after you've got all this set up here, what we need to do is, you can see the fillet gives us geometry going that way, but it's just straight lines going up like this. There's no other geometry there. So in order to fix that, to give us more edge loops, we're going to resample this curve about the same amount as we want for our resolution. And that's something. So now, whatever this number is, we can change it, and the resolution just kind of works. It does break at a certain point, so you don't really want to go over, I think I would stick to 25. All right, so that takes care of that. So for this curve line, I want my height to be a specific number. So I'm gonna do a combine XYZ, and then I want this number to go into the group input. And we will rename this column height. So we have our column where the height is adjustable here. How do we get those like block shapes right here that go on the thing? You guessed it. We're going to use the cube. It's crazy, huh? Crazy how that works. So we are going to instance on the original curve line, the one that only has 2 points. We are going to instance on points, on these points, this cube. And you see something going on here. This number is also 25. So guess where that's going to go? You guessed it, into the resolution. So that's going to go both X and Y vertices. That way, our geometry can be nice and square. And this is going to act as your thickness. We have our cube instanced on the line, but if you look from the side view, you can see this cube is not on the floor. So what we want to do is we want to transform that geometry by a certain amount, which seems to be about half of the thickness. So we can do another combine XYZ, thickness multiplied by 2. So when I control the thickness of this, it is now controlled based on the floor origin. We have most of our cube done. What I add as an artistic touch is a subdivision surface, which is going to subdivide our mesh a little bit. And let's see, if I have it at 0, it's kind of rounded, but it looks better this way. Gives you a nice bevel on it. There's other things you can do here. If you don't want to instance this cube, you could just find something on the internet that you want to instance on it as the column or whatever. Doesn't really matter here. And then I set that shade smooth. So now we have our cubes and we have our cylinder shape. So like, let's put them together. You may be thinking, let's just do a join geometry, right? Yeah, that's fine. You can do that. But if you really want these edges to go away, we have enough resolution on both the cube and the cylinder to just join those together a different way. So if we add a subdivision surface here, that's going to smooth in all of these faces. And now we have this much resolution. Very, very dense geometry here. But all of these inside faces, we're about to get rid of those with a merge by distance. And instead of a join geometry, we're going to do a mesh boolean. What is a Boolean, you say? A Boolean is an operation between two meshes where one is joined to the other one or subtracted from the other one. And as you can see, with that merge by distance, cleans up some of our excess vertices here. Without width, we literally take away like 20,000 vertices by using this merge by distance. Nice and clean. What's left? If you like the way that it's turned out and you want to use this for other geometry nodes groups, this will come in handy, especially for whenever we go to destroy this mesh that we just created. Now that we have all of that set up here, there's a couple things that we can do to make it look a little bit better. For our star radius, say we want this star radius to be bigger. It's not moving because we baked it. So let's delete this bake. So we have our cubes instance on each of our points here, and that's going to be at the very end point. I want the width of this cylinder to be a specific distance away from the edge of the cube every single time that I'm scaling it to be a wider cylinder. So I think what I'm going to do for that is I will take this and put it in here. This is going to control the column width. So that gives me the square, or the cube, right? Okay, so I want that number to be tied with this down here. So I can take the column width divided by whatever my margin is and put that into my outer radius. Now I want to control my inner radius too, so since I like having it be about 0.02 meters different, I'm going to put this divide into my subtract into the inner radius, this into the outer radius, and it looks the same. If I go to column width, I can change the width, and it does break after a certain point, so we need to control that as well. So I like the width of 1. Kind of big. Let's bring our thickness up a little bit as well. And our height, let's put that at 5. So in order to make our resolution work properly with both the cube and the curve, I resample the curve based on the height. So now this height is going to continually give me the proper amount of topology, and we have our column. The last thing we need to do, we'll just bake it and set material and add a column material to it. Now we're going to get into this a little bit further whenever we get to the next video, but for now we can just do a simple maybe brown color or tan. Let's do tan. Add a light so you can see it. Add another light so you can believe it. And you have some pretty nice texture on here. If you want like a toon shaded look, that could look pretty cool. If you have it metallic, that's one way to do it. Now we have all of this set up pretty nicely here. We can exit out of this and go to a new geometry nodes and call this column A. All right, so now we have this plane here that we don't need, but this is what we're working with here, this plane. You can scatter this on a surface, and we'll take this and just type in column. We can do column generator tutorial because that's the one that we just made, and then put this into the geometry instance, and bam, we have it there. And we can adjust our resolution, our column height, and if you want, you can take this, scale it up, and apply that scale. If it's not what you're desiring, you can change this, scatter on surface. This node is super powerful in 5.0. Just go to Poisson disk, density of 1 is fine, and put the minimum distance to be 1 meter. Now they're all going to be at least 1 meter apart. And just like that, we have all of these scattered on the surface. Realize those instances so they're actual geometry for later. And transform, randomize. You want to change this rotation to 360 degrees. So it rotates all of them around 360 degrees at a random state. Random scale, we'll do 1, kind of like this. So now there's taller ones and shorter ones, and gives a little bit more texture to it. Depends on what you want to go for. I kind of prefer it with no randomness, so it looks more uniform / scattered. All you need to do now is add a bunch of rocks to this, and you have yourself a little pillar cave scene. And this is going to show you realize data and input geometry is ignored. Pick instance is on, but there are no instances to pick from. So we can just turn that off. We don't need it. And there you go. There is your column generator. You can change this resolution to 25, change the thickness of the cube, and that is going to actually change the thickness and do the Boolean operation. Once you find a column you like, you can leave it be. You have that arrayed there, and then add another any object here, and that can become your new centerpiece column. All right. And if you're wondering what that red is, it's literally just I have face orientation turned on. If you see that, you don't like it, that just means that your normals are wrong and you need to fix it. So I think that is going to conclude the video for now. If you enjoy the video, make sure to give it a like and subscribe for more content just like this. I'm Brandon, and I'll see you in the next one.